Uh, this is such a nice algebra problem. K plus 7 all raised to 4 equal to 81. How do we find the value of k? Without further delay, let us begin. K plus 7 to the power of 4 could be written as k plus 7 all squared times 2 equal to 81 to the power of 2. Let's continue. This implies that. Now, let us move 9 squared to the left hand side. That becomes k plus 7 all squared times 2 minus 9 squared equal to 0. At this stage, let us recall this very beautiful property. This is a difference of 2 square. It says a square minus b square is equal to a plus b times a minus b. This is a difference of 2 square formula. Applying this identity to this guy, first you will notice that k plus 7 all square is what? Is a. Why 9 is simply equals to b. So applying this identity to this guy, we simply have k plus 7 all squared plus 9 times k plus 7 all squared minus 9 equal. Let's proceed further. So if you expand, you're gonna have k squared plus 14k plus 49 plus this particular 9, close the bracket, times expanding this also square plus 14k plus 49 minus this particular 9, everything equal to 0. Let's proceed further. So k square plus 14k plus 49 plus 9, that is what? That is 58. Close the bracket, times k square plus 14k. So we have plus 40 equal to 0. Let's proceed further. This implies that k square plus 14k plus 58 is equal to 0, or this particular guy, k square plus 14k plus 40 is equal to 0. Now, let's solve these quadratic equations one by one. Let's solve this guy first. You will notice that this quadratic equation is not factorizable. We can only solve it using quadratic formulas. K equals to minus b plus or minus the square root of b square minus 4 times a times c divided by 2 times a. That's the quadratic formula we're going to use to solve it. From this equation, the value of a is 1. That's the coefficient of k square. And b is equals to 14, coefficient of k. Y c is equals to what? Is equal to 58. This is 58. Let's proceed further. K equal to minus, what is b? B is 14. 14 plus or minus the square root of 4 into a is equals to 1 and c is equals to 58. All divided by 2 into, what's the value of a? The value of a is 1. Let's proceed further. K equal to minus 14 times 58, that is 232, all divided by simply 2. K equal to minus 14 plus or minus square root of 196 minus 232, that is minus 36, all divided by 2. Let's proceed further. K equal to minus 14 plus or minus. I can rewrite square root of minus 36 as square root of 36 times square root of negative 1 divided by 2. K is now equal to minus 14 plus or minus. What is square root of 36? That is 6. But don't forget, from the complex number is equals to I. So we have I here, all divided by 2. Let's proceed further. K is equal to, fact, if I do that, I simply have minus 7. So K equal to, clearly 2 cancels 2. We are left with minus 7 plus or minus 3i. This implies that K is either equal to minus 7 plus 3i, or K is equal to minus 7 minus 3i. You will notice that we have two complex solutions here, two distinct complex solutions. Now, let's consider the other quadratic equation that we have here, k squared plus 14k plus 40. If you look at this quadratic equation very well, you will see that it is factorizable. Yes. So let's do that. Let's factorize it. K squared plus 14k could be written as 10k plus 4k plus 40 equal to 0. From here, k is common. I can pull it out. So I have k into k plus 10 plus, if you look at these two guys also, I can factor out 4. So that will be 4 into k plus 10 equal to 0. What is common? K plus 10 is common. We can also pull it out. So that will be k plus 10 times k plus 4 equal to what? Equal to 0. This implies that k plus 10 is either equal to 0 or k plus 4 is equal to 0. This means that k equal to minus 10 or k equal to minus 4. You will see that while solving this particular quadratic equation, we have two real solutions, which are k equals to minus 10 and minus 4. So as a result of this, let's got, therefore the required solutions are, let's start from the row minus 10 and also k equals to minus 4. Let me confirm that. Yeah, correct. And the two complex solutions that we obtain are these two. We have k equal to minus 7 plus 3i and k equal to minus 7 minus 3i. Let's call this k1, this k2, and this one k3, and this k4. You will see that we have 4 distinct solutions rather. for this particular algebra problem. That's it for this video. Thank you so much, guys, for joining this live session video. Please share your tips and please tell me if this was helpful. And don't forget to like and subscribe to my channel. I would love to see you in my other videos as well. Have a good one.